And the good news is we had serious volumes of water in both of the wells, and we conducted the required pumping test on the wells, 72-hour pumping test. Both were conducted at about 20 gallons a minute, and the wells performed really well. No pun intended. But unfortunately, both wells showed concentrations of arsenic above the drinking water standard. So to use these wells will require treatment to remove the arsenic. And our original plan with drilling these two new wells was to basically continue to use the existing wells, but bring the new wells online, and hopefully by backing off the existing wells, allow those wells to kind of recover back to some of their original water levels and pumping levels. And you know, that's still our plan. On paper, the two new wells, the safe yield that I'm gonna ask the state for would essentially would meet your entire system usage. So if those wells were free of arsenic, we could almost say, let's just plan on connecting these two new wells with no treatment, and we won't even need the existing wells. But based on the history of the existing 4 bedrock wells, the yields are basically, of even these new wells, are likely to decrease through time. So the plan is still to add these new wells into the system and continue to use the existing wells, but hopefully backing off the pumping rates or the durations of the existing wells and allowing them to recover. So we're basically just kind of spreading the pumping stress out over what will be 6 wells. But to do that is going to require treatment for the 2 new wells. And so that basically takes it up to the engineer, Wayne, to look at the options for treatment for the 2 new wells.
That's why we're here.
Yep. So, just conceptually, I guess the 3 options that we would have, you know, if we tie those 2 wells in, we could run an isolated separate pipeline all the way up the hill to the reservoir, go through that treatment system. The limitation we have with that is, it was designed for 20 gallons per minute, so, you know, that's gonna get you running 12 hours a day on a given well. You know, that's gonna give you about 14,500. You would have to run probably, maybe like the 2 new wells, you'd have to run each of those like 12 hours a day. And if you did that, you could get up over and meet your, you know, current day water demand. So that's up there. That would take a completely separate pipe up to the treatment system, and then through that. Another option is to move that down to roughly where the HSA wells are, you know, set that up, and we could run those 2 new wells through the treatment system. That would preclude the option of using the top well, you know, that was placed into service here recently. The third option is to leave that treatment system up where it is and, you know, drop a new treatment system down roughly where the HSA wells are, to bring those 2 new wells through, so. And tonight, I mean, we're just kind of throwing out ideas. I guess the objective really tonight is to figure out what the next steps are. Because if Jeff said, you've got plenty of water here, if it wasn't the arsenic issue, you know, we'd be ready to tie those in and drop the well pumps in and go forward. I didn't want to get too far ahead of ourselves here, because until we got the results and the water chemistry back, you know, if we needed to do something different, we obviously didn't want to do things twice here, so. So today's just kind of to lay out those conceptual options, I guess, and figure out where we go from here. I guess my recommendation right now is you do have a planning loan at the state, so that was used, or that funding was used to drill the 2 new wells and do all of primarily Jeff's work on the hydrogeological side. That's still there. What we could do is go back and amend that and do this preliminary engineering study, so you are on the state priority list, on the drinking water priority list. So we could amend that. You guys do qualify for some loan subsidy there. And the purpose of that initial study is just to briefly look at these 3 options. One of the things that I think is important to look at is not just the capital side of the construction cost, but the operations side. There's a treatment system that you have up there, you have to replace the media up there every couple of years, and we did that for a couple of reasons, is that you really weren't that close to your municipal sewer system, so it would have taken quite a bit of pipe downhill to do that. And if we're gonna consider that option further, we also recognize there's limitations with your treatment system, you know, from a capacity thing, so that's something we just wanna look at pretty carefully, so. So we look at the three options, kind of the pros, cons, size those up, you know, look at the capital costs. My recommendation, I guess, from a funding standpoint, once we get the numbers together and kind of get a preferred approach, is, and that's gonna be a decision that's made collectively here, is to pursue the USDA funding. You are in the REAP zone up here, so any of these communities up this way, you know, you're eligible for up to the 75% grant. So that's another reason, again, why we wanna optimize the capital costs, because you're getting the grant money up front versus on the back end with the operating costs, which you can't get any help with. So once we had an approach, we would put a funding application together and get that into USDA. We've got probably a rough idea, you know, of what you would get for a possible grant loan. You do have to have a positive bond vote before they'll issue a formal funding offer. So realistically, to kind of go through that, the thing with USDA, you know, it's a great opportunity. It's, you know, there's a lot of money there. They're pretty aggressive for the communities up here, but it takes some time. That's nothing we're gonna turn around in 2 or 3 months. It may take 4, 5, 6 months before you really get an official offer. So, you know, laying that all out, you know, you're really looking towards not building anything until next year. And the strings tied to their funding program is, you know, you've got to put the project out to bid, you know, got to be a competitive bid with contractors and all that, you know, with the conditions of their grant loan program, which I know you guys have been through in the past, so.
Great. What are your thoughts?
I have a question on the well that's right beside the reservoir. Is that something that we're gonna be allowed to use until we get these new wells online?
Yeah. Steve asked me that question before. I don't know the answer to that, but it's something we can definitely check into with them.
So that's saving our bacon
I
right
know
now.
it is, yeah. And my hope is, as long as you're showing progress and they kind of understood the situation is, that they'll be somewhat flexible on extending.
We're moving this forward as fast as we can.
Yeah,
you
I
know,
know.
it's-
So I'm
it's- but-
hoping they'll provide you some flexibility there.
Right.
Yeah, hey, well, how much money are we looking at for, put up that, treatment plant?
What treatment plant?
Well, that, arsenic, for the arsenic.
Oh,
The one-
treatment plant, I thought you were sewage
We-
plant.
No.
Don't know.
Yeah.
Well, he must have an idea.
I really don't, Ernest. I can tell you what we spent on the other one up there. That was done, you know, pretty cost effectively. Final numbers on that, I think I'm guessing $80,000-$90,000 range. I'm guessing it was under 100,000.
Okay.
You know, and that was done, you know, the town went out and hired a builder, you know, bought the equipment directly. Pretty minimal engineering in that, because you guys kind of paid for it out of, you know, local funds. And so we tried to, you know, work out, you know, you hired somebody to install it for you, so. A little harder to do that with USDA, you know, with their programs set up, so. And then we could also, you know, we're probably also looking at something that's larger from a capacity wise, because I'm guessing, you know, that's 20 gallons per minute. You know, we probably want to upsize that if we're looking at a couple of wells, maybe. I'm just putting a number out there, but I don't think 20 is probably the right number, so it may be 30 or 40 gallons per minute, so.
From what I'm hearing, it would make more sense if we put in something down below here and capture everything,
Yeah.
and then take that one offline up there.
Yeah.
Maintenance wise, instead of having 2 facilities to look after, you just have one. I mean, but I don't know if that can be.
But with taking off that one up top, that would eliminate that top well.
It would what?
Eliminate
Yeah.
that top well.
That's
We
right.
would no longer be able to.
We
pump
can't pipe that one down through.
Well, you would have to, but that's
you
that's a
could.
lot of infrastructure.
you could.
Yeah.
A lot of infrastructure. that-
Yeah.
Mike, we would pump everything. I asked Wayne earlier if we can pump directly through the treatment and right into the village and we can do that.
Okay, I was just, you're
So it'd
gonna
put a
rearrange
system
your
in
infrastructure.
that would
Yeah.
capture
Yeah.
all wells.
How
Well-
would you coordinate that?
But yeah.
Right, it'll all be done in one location.
Yeah, I don't know if we can tie that top well if we bypass the treatment system though, because we gotta bring that water all the way down. You know, that's also gotta go through the
Just dump it
nutrient.
in the reservoir.
Well, I mean, if you didn't wanna use the treatment system up there though, remember the top well's already exceeding the arsenic limit, I think.
Right, but he's just saying dump it into the reservoir,
Yeah.
and then from the reservoir, bring everything down to,
No, you can't do that, cause that's your fire protection.
We have no fire protection.
Well, in theory, yeah, in theory, you gotta do. Yeah, that's a whole nother discussion, but, yeah, cause you gotta grab, what you would do is if we do the arsenic treatment system, let's say down by the HSL, you're gonna just pump directly through the pressure vessels. From there, it's gonna go right into the distribution system. And that water's gonna go in either direction, depending where the demand is. It's gonna come down here and.
So you
build-
can't like come back on this set of railroad tracks and capture the main line coming right out of the reservoir.
You can, but when you're pumping into that, it's gonna go wherever, it's either gonna go down into here if there's a demand, or it's gonna go back up to the reservoir. You can't isolate the top well without bringing that down. Yeah, I understand what you're saying, Steve, it wouldn't be, you'd have to,
It would make more sense then to pump the two wells up to the reservoir
There
there,
you got the village.
well,
and increase the size of that.
Cause what happens is your reservoir is maintaining your system pressure here. Cause basically what you're doing is, you know, you get your water, and I'll just do this in sections, so you get your reservoir up here and you get the village down here. And this is where you're getting your system pressure. And what we're doing now with the top well here is that's pumping through the treatment system. And then we're breaking gravity and going into the reservoir directly. But what you'd have to do here is, the way the treatment system works here is it would have to be back into here. So the wells would pump through that, and you'd still be pressurized on the back side of this. Cause if you did it here, Steve, what you'd have to do is basically you'd have to run your pumps all the time to maintain your system pressure. If you're trying to do the treatment system.
How does the HSA get into the village now?
It just goes directly into your distribution, so basically what's happening now is that water is just kind of going wherever it's called for. The well comes on, if you get a demand in the village, some of that portion's going to the right, the rest of it's going up at the reservoir, you know, basically to maintain the
So
level.
the HSA wells are not treated.
No.
They're chlorinated.
Well,
Okay,
yeah,
chlorinated, but not-
chlor-
I'm talking
yeah, that-
arsenic.
And that is a
Yeah.
form of treatment, so.
Yes,
so-
arsenic.
So, yeah, so
Yeah.
when they're pumping in, they're going either way. So what we would have to do back down in here, you know, if we didn't run the HSA wells through here, we'd take the two new wells. And, you know, basically what we would do is pump through the treatment system. And that would function the same way as once it's in here, it's gonna go either way, it's gonna go down. The only way that we could make that work
Got it.
is, so either we would have to, if we were gonna take the HSA wells all the way up there, it'd have to be a completely separate pipeline and go through the treatment system and into the reservoir. And the thing, we gotta be a little careful with the reservoir is technically that's providing some fire protection too, so, you know, that water level up there is maintaining your system pressure, so gravity.
And in order to bring from well A or B or whatever it is up top, you'd have, if you did away with that top arsenic plant, you'd have to run a separate line to the new treatment plant down below.
That's right,
Right,
yeah, so
right.
you'd have to come all the way from here separately and then go through the treatment system. That gets a little weird, because what's gonna happen is you're gonna pump out the well, and it's gonna gravity, and you'd have to build up enough pressure to get it through the pressure vessel. That's because it's up top and it's outside the grade line, I'd have to think about that, but you have to boost the pressure to get it through here and back into the distribution system.
See,
so.
my simple mind, I just
Well,
put
I
a
know.
check valve on there so it
I
could
know.
go back to the reservoir, but
My thing is keep it simple, and that's the beauty, if you do this with the treatment system, is you're just gonna pump through the vessels and you're going right into the distribution system, otherwise you've got these isolated lines that you have to go, but that's kinda drilling into the details of something.
you would capture HSA 1 and 2 through the treatment. If we're gonna
We
do
have
this.
that option, but I think what we would do is, depending on the water chemistry and the quality, we'd set up a bypass mode there too. So if you didn't have to go through the treatment system, we wouldn't want to again. That depends a little
Yeah,
bit.
just put them all
Historically, their
together.
arsenic levels have been good.
Yeah.
Yeah, I was gonna say, you can't just put them all together and blend it through and.
Well, I wouldn't, because if they don't need to go through the treatment system and you can get as much water as you can out of those, then we're not, drawing down the media or reducing that. And
There's
one of-
iron and manganese and then bottom ones, and they'd be clogging the media up
That's
faster
right,
than you'd want.
that's one of the issues here a little bit. We need to be careful with the absorption media that we have in the treatment system up there. The iron and manganese will shorten the life of that media somewhat too, than if you're just dealing with the arsenic. So that media doesn't just remove the arsenic, it also removes the iron and manganese, and that's gonna further shorten the life of that up a little bit too. That's why there's no guarantees, but I would like to look at a backwash system, because that would get you out of the having to replace the media every couple of years at significant cost. But again, we need to be a little bit careful about putting that in your municipal sewer system, because that's got also some impacts there, and we've got some limitations there, so. Okay, so this type of treatment system, that if we could go into the municipal, that's identical to what Troy has, that's by the road. Now, that's a 50-gallon per minute system, so that's a little bigger than what you need, but, yeah, there's some,
So it's an operational thing,
Choice
like
of arsenic and manual one,
two
too.
plants.
Yeah, I heard.
But like right now with the top, with our emergency source taking the pressure off the wells, we get a good 22 gallons a minute, 21 gallons a minute through that top plant whenever it's on.
Yeah.
There hasn't been any decline, which is what we were seeing previously. It works great. Right now, things are great.
what are you running that up there, Mike, the top one, or 12 hours a day or something, or?
It varies, cause I do control my chlorine residual in the reservoir with, cause that emergency source just goes in and gets its contact time
Yeah.
from what I put through the arsenic plant for chlorine, so some days I run it more, some days I run it less, just to kinda keep my chlorine where I want it, and
So that running 12 hours is gonna get you, 15,000 gallons per day, which is quite a bit of your demand.
Yeah.
The other thing with the treatment units is sometimes we'll look at 3 vessels, each one's kind of 50% of the capacity, so that's kind of back to some cost. Depends a little bit on the size of too, but. Okay. Sorry to mess up your
No,
chalkboard.
that's
things.
fine. My simple little mind is a pipe,
Well,
runs downhill and.
Yeah.
My thing is to keep it simple too, because it's not that you can't do all that stuff, but there's a complication, there's a cost associated with it too. So our objective here, whatever we do here, is want to make sure it's.
So if I'm getting your recommendation, you would like to see us put in a new plant, a new,
No, I want to look at the options.
You wanna look at
first,
the
and
options,
just look at
okay.
the pros and cons, because we need to drill into the details of this just a little bit more.
Okay.
I want to see what the capital back, Ernest's question about what's the cost.
Right, right.
I don't know, and we need to just look at these 3 options, conceptually, not just the capital, but also the operating cost side too, Rick, so.
I think we make a motion to allow Holdridge and Elliott's Associates to explore the different options for us as soon as possible, so that we can move forward.
I'll second that.
Okay, can you repeat that one more time?